Good day, students. Welcome to this JSS 1 Basic Science lesson on light, its properties and importance. Light is perhaps the most fundamental form of energy in our world. Without light from the sun, there would be no photosynthesis, no warmth, no visibility, and no life on Earth as we know it. At the same time, light behaves in fascinating ways that have led to technologies including fiber optic cables, solar panels, cameras, medical endoscopes, and telescopes. By the end of this lesson, you will be able to define light and describe its properties, explain reflection and the laws of reflection, explain refraction, describe dispersion of white light into a spectrum, classify objects as luminous or non-luminous, and state the importance of light in biology and technology. Let us begin. What is light? Light is a form of electromagnetic radiation that travels as transverse waves. It does not require a medium, it can travel through a vacuum, unlike sound. Speed of light in vacuum, 300,000 km per second, 3 times 10 meter per second, the fastest anything can travel. Visible light is just one small portion of the electromagnetic spectrum, which, from low to high frequency radio waves, microwaves, infrared, heat radiation, visible light, ultraviolet, UV, X-rays, gamma rays. Luminous versus non-luminous objects. Luminous, objects that produce/emit their own light. Examples: sun, burning candle, stars, firefly, bioluminescence, electric bulb, fire. Non-luminous, objects that do not produce their own light, they reflect light from a luminous source. Examples: moon, reflects sunlight, people, rocks, trees, books, the moon, a mirror. Transparent, allows light to pass through clearly, you can see through it. Examples: clear glass, clean water, air. Translucent, allows some light to pass through but scatters it, you cannot see clearly through it. Examples: frosted glass, oiled paper, wax paper. Opaque, does not allow light to pass through at all. Examples: wood, stone, metal, walls. Shadow, formed when opaque object blocks light. UMBRA equals full shadow, total darkness, penumbra equals partial shadow, around the edge of the umbra, some light reaches. Rectilinear propagation of light. Light travels in straight lines, rays. Evidence: shadows are formed, a pinhole camera forms an inverted image. Pinhole camera, camera obscura, a box with a tiny pinhole on one face. Light from a bright object passes through the hole and forms an inverted, upside-down, diminished image on the opposite face. No lens needed, pure rectilinear propagation. Reflection of light. When light hits a surface, it bounces back, this is reflection. Laws of reflection. 1. The angle of incidence equals the angle of reflection, angular equals angular. 2. The incident ray, the reflected ray, and the normal, a line perpendicular to the surface at the point of reflection, all lie in the same plane. Normal, a line drawn perpendicular, 90 degrees, to the mirror surface at the point where light strikes. Types of reflection: regular, specular, reflection. Parallel rays reflect in the same direction, from smooth surfaces, or mirror, calm water, polished metal. Diffuse reflection, rays scatter in different directions, from rough surfaces, paper, rough wall. We see most objects by diffuse reflection. Image in a plane mirror, virtual, cannot be projected onto a screen, same size as object, as far behind the mirror as the object is in front, laterally inverted, left-right reversed. Refraction of light. Refraction is the bending of light as it passes from one medium to another of different density, optical density. Light bends towards the normal when slowing down, entering a denser medium, e.g., air, glass/water. Light bends away from the normal when speeding up, entering a less dense medium, e.g., glass, air. Refractive index, NN equals speed in vacuum/speed in medium. Everyday examples: a straw looks bent in a glass of water, objects appear closer when viewed through water, fish appear shallower than they really are, a coin in a bowl of water appears to rise when water is added. Total internal reflection: when light hits the boundary of a denser to less dense medium at an angle greater than the critical angle, it reflects back entirely, no refraction out. This is the basis of optical fibers, used in fiber optic cables for internet and medical endoscopes. Diamond sparkles because of total internal reflection within the stone. Dispersion of light. White light is a mixture of all visible colors. A prism, triangular glass block, separates, disperses, white light into its colors by refraction. Each color refracts at a slightly different angle. Visible spectrum: red, orange, yellow, green, blue, indigo, violet, Röntgen. Red has the longest wavelength and refracts the least. Violet has the shortest wavelength and refracts the most. Rainbow, formed when sunlight is dispersed by water droplets in the atmosphere. Each drop acts as a tiny prism. Primary rainbow: red on outside, violet on inside. Nigeria's rainy season frequently produces stunning rainbows. Importance of light. Biology: photosynthesis, light chemical energy in plants, vitamin D synthesis in human skin, sunlight, vitamin D, UV vision, eyes detect light. Technology: fiber optics, telecommunications, internet, medicine, solar panels, photovoltaic effect, light, electrical energy, cameras, lasers, cutting, surgery, barcode scanning, greenhouses, amplify sunlight for plant growth. Nigeria: solar energy, converting sunlight to electricity is transforming rural electrification across northern Nigeria. 3 examination questions. Question 1. A ray of light strikes a plane mirror at an angle of incidence of 40 degrees. Calculate the angle of reflection and the angle between the incident and reflected rays. By the first law of reflection, angle of reflection equals angle of incidence equals 40 degrees. Angle between incident and reflected rays equals 40 degrees plus 40 degrees equals 80 degrees. Question 2. Explain why a straw looks bent when placed in a glass of water. The straw is partly in water and partly in air. Light from the submerged part of the straw passes from water, denser, lower light speed, into air, less dense, higher light speed, at the water surface. As it crosses the boundary, it refracts, bends away from the normal. Your eye receives the refracted ray and traces it back in a straight line, making the straw appear to be at a different position than it actually is, so it looks bent or broken at the water surface. Question 3. Why does a rainbow appear after rain in Nigeria? During and after rain, water droplets remain in the atmosphere. Each water droplet acts like a tiny prism. Sunlight entering a droplet is refracted, then internally reflected from the back of the droplet, then refracted again as it exits. Each color, wavelength, in white light refracts at a slightly different angle. Red refracts least, violet most. This separates the colors into the visible spectrum, Röntgen, which appears as a rainbow arc in the sky, with the sun always behind the observer. 3 common mistakes. Mistake 1. Measuring the angle of incidence from the surface rather than from the normal. The angle of incidence, anguli, and angle of reflection, angular, are always measured from the normal, the perpendicular to the surface at the point of contact, not from the mirror surface itself. If the normal is at 90 degrees and the ray hits at 30 degrees from the normal, then angular equals 30 degrees, not 60 degrees. Mistake 2. Saying light travels through all materials at the same speed. Light only travels at 3 times 10 meters per second in a vacuum. In glass, light travels at about 2 times 10 meters per second, in water, even slower. This change in speed is what causes refraction. The speed depends on the optical density of the medium. Mistake 3. Confusing the spectrum order. Red is on the outside of a rainbow, least refracted, longest wavelength. Violet is on the inside, most refracted, shortest wavelength. Memory: Röntgen in order of decreasing wavelength and increasing frequency. Summary: light, electromagnetic radiation, travels at 3 times 10 meters per second in vacuum, no medium needed. Luminous, produces light, sun, fire, Bulb versus non-luminous, reflects light, moon, paper. Transparent/translucent/opaque, light passes through entirely/partly/not at all. Rectilinear propagation, light travels in straight lines shadows. Reflection, angular equals angular, normal is reference line. Plane mirror image, virtual, same size, laterally inverted. Refraction, bending of light at boundary between media of different density. Total internal reflection optical fibers. Dispersion, prism/raindrop separates white light Röykbeef, red equals longest wavelength, violet equals shortest. Importance, photosynthesis, vision, solar energy, fiber optics, cameras, lasers. For homework, A. Draw and label a reflection diagram. B. Explain why a fish in a pond appears shallower than it actually is. C. Name the colors of the spectrum in order. D. How is a rainbow formed? Attempt a quiz on your LMS. Keep exploring the world around you. Visit Lightech Academy at academy.lightech.com.ng. Until next time.